Welcome protein coders, let's build some coding muscles. Today we're gonna see Euler path. Let's say you have a garden like graph 1 and you have your plants around the edges and you need to water them. Okay? So how will you do it in most efficient way? So in that scenario, our Euler path comes into picture. The most optimal way can be that we visit every edge single time, right? That's what Euler path is. It's a path in a graph that visits every edge exactly once. Let's see. So let's try to draw a path in graph 1. If you see in this path, we have visited some edges twice. So this is not a Euler path. Let's try some other way. Like this, if I move, you see I visited every edge once, right? So it's a Euler path. I can say that this graph has a Euler path. Okay? Now let's see in the example 2. If I move from this node all the way to here, you can see we found a Euler path. There is one node which is not visited, but it doesn't have any edge, right? The Euler path talks about edges, right? There is no unvisited edge and we visited every edge once. So we can say it has a Euler path. But in case 3, you see we have a unvisited edge, right? We have a separate component which has an edge. So in these cases, we can't have a Euler path. Now let's see Eulerian circuit. What is Euler circuit? A Euler path which has the starting and the ending or destination node same. Okay, that's when we call it Euler circuit, that this graph has a Euler circuit. See in graph 1, I can start from the same node and can come to the same node at the end, right? So we can say it has a Euler circuit. And Euler circuit has a special property. If I can start from any node in the graph, I can find a Euler circuit. I can come to this node again. So from every node, I can have a Euler circuit if there is a Euler circuit present in my graph. See in the node graph number 2, example 2, I ended up at the same node, right? It has few visited nodes, but they doesn't have any unvisited edge. So yeah, it's a Euler circuit. But if you see in the graph 3, yes, we can come to the same node, but we have few unvisited edges. Okay, they are not in the same path. So this graph doesn't have a Euler circuit, neither it will have a Eulerian path. Now I want you to have an observation. See for the degrees of the nodes in the Eulerian circuit graph. They are all even. Okay, so this is a very crucial information here, that degree of every node in the Eulerian circuit will be even. Okay, that means for every incoming edge we have an outgoing edge, which means when we come to a node, there will always be a way to go out of the node. Okay, and the other observation is that all the edges should be part of a single component. Okay, the different components should not have unvisited edges. Okay, similarly, if we see in degrees of a Euler path in our first graph, you can say we have 2 odd degrees, right? If we have an edge between these 2 nodes, then we will have even degrees and it will become a Euler circuit. So what we observe from here is we got 2 observations again, that for Euler path, in degree can be all even or can have exactly 2 odd degrees. If they are even, then yes, it is a Euler circuit. Okay, Euler circuit, if there is a Euler circuit, then there will be a Euler path, and all edges should be part of single component. Let's see the code for this function. We have a number of nodes, adjacency list, and we will return 2 for Euler circuit, 1 for Euler path, and else 0. Okay, so first let's create a vector degree and then an integer odd degree which will store the count of odd degrees. Then we will iterate over the nodes. Okay, and how to get degrees? Adjacency list size, right? adj I of size of adj. Then if degree is odd, then we will simply increase the count of odd degree. Now if the odd degree count is not equals to 0 and also not equals to 2, then we will simply return 0. Okay. Now let's do our DFS traversal, have a visited vector, and if we got a node which has some degrees, we will call a DFS for single time. Okay, DFS or BFS for single time. Then we get our visited vector and we have a degree vector. Okay, now see very carefully. Suppose we have a node which has some degree, some positive degree, 1, 2 or something, and it is not visited. That means we got a component which has some edges which is not visited. In that case, we will return 0. So let's write code for this. We will traverse again for int I equals 0, I less than vi plus plus. If it is not visited and it has some degree, we will return 0. And at the end, if all cases are fine, then we will check if odd degree is equals to 0, we will return 2, or else we will return 1. 2 is for Eulerian cycle, 1 is for Eulerian path. So thank you for listening, guys. That's all from my side. If you have any questions, queries, please mention them into the comment box. You can find the problem and the complete solution link into the description box. If you don't understand, don't like, don't subscribe, but if you do, please show some support. Keep smiling, keep practicing. Thank you.